Hi everyone, and hello to Bailey and Valerie, and Olive and Athena and Hendrix. Today we're going to take a look at dry ice. Now we don't normally keep dry ice around the house, but we had some food delivered that had to be kept cold, and it was packed in dry ice. Now what is dry ice? Well, you know what ice is. Ice is water that has been frozen. It's very cold. You get ice cubes, you get chipped ice, or you get ice on the highway, which makes it slippery. Okay, that's water below the freezing point. Dry ice is carbon dioxide that has been frozen. Now you remember we've talked about carbon dioxide before. It's what animals, human beings or animals, breathe out, and that's what green plants take in. Well, if you get carbon dioxide cold enough, it'll freeze. Now it won't condense, it'll freeze. It sounds crazy, but its boiling point is lower than its melting point. So it goes straight from a solid to a gas. Well, right now we have it in a solid state inside this bag, okay? And it won't stay that way long because, of course, we're at room temperature, and that solid's going to melt. And by the way, don't ever try to handle dry ice with your bare hands. It is so cold that it will cause you frostbite. I'm going to pour this dry ice into a glass of water. You know what that is? That's the carbon dioxide boiling and is turning into gas. Now the carbon dioxide gas itself is invisible, but it is so cold that the water vapor in the air condenses and forms a cloud. So what you're looking at now is boiling carbon dioxide. Now let's see how long it boils and what we end up with. Now if you look very closely through the cloud, you might see bubbles in the water. That's carbon dioxide gas. The carbon dioxide gas comes up to the top and escapes, but it's so cold that it condenses water vapor in the surrounding air. Now keep watching. Let's see what happens if we can get all of the carbon dioxide to melt and boil. Now, have you ever been to a show or a movie or a stage production where they have a cloud coming across the stage? That's what they use. A lot of times they'll use that, carbon dioxide, because that's the effect that you get when you pour carbon dioxide into water. Now let's keep watching until it is all turned into a gas. Okay. And once it's all turned into a gas, it's still going to take a little while, but let's see what happens to the water. If I hold the outside, touch the outside of the glass, that water's cold. But it hasn't frozen. It hasn't gotten that cold yet. Because remember, heat energy is coming back in to the water from the top to replace some of the heat energy that's taken out. Now, the other thing I want you to remember is that dry ice doesn't put cold into anything. It takes heat out. Cold is nothing but an absence of heat. So at freezers and dry ice and refrigerators, don't put cold into food. They take heat energy out. And if it's dry ice, once again, it produces carbon dioxide. You notice the cloud has got a little bit smaller? That's because most of the carbon dioxide has already vaporized and is gone. There's just a little bit left. Keep watching now, and we'll see what happens when the last of the carbon dioxide is gone. I thought it might freeze the water, but evidently that's not going to happen. But that water is going to be pretty cold. before all the carbon dioxide has turned into gas. Now what's nice about this is that the carbon dioxide itself never gets wet, so it doesn't spoil the packaging that it's in. That's why they call it dry ice. But again, what it really is carbon dioxide that is frozen. Well, it's almost done. Just wait a few more minutes and see what happens when it's finished. Just a wee bit left. Can you see it down there? All the way down on the bottom of the glass. Just a little more. And a little more. Not much left. So there's not that much condensation. Because there's not that much water vapor that's being made cold. Just puffs once in a while. Now one reason why, now you don't ever want to use dry ice to drink something. Okay? It would make that much too cold. You could actually damage your lips and your tongue drinking this. If you got a piece of that dry ice inside you, it might even kill you. It certainly won't do you any good. Now, one of the reasons why the reaction has slowed down so much is because the water has gotten cold. See, the warmer a substance is, the faster a change will occur. So when the water was at room temperature, the dry ice vaporized really, really fast. But now the water is getting down very cold. It's almost down to its freezing point, and that slows the reaction down. But it's still going. Now it's getting to the point where I can look down from the top and see the carbon dioxide that's down the bottom. And it's still making bubbles. It's still dry ice turning into carbon dioxide gas, but it's just happening much, much more slowly. What we don't have is a thermometer to measure the temperature of the water. But I can tell you for sure, that's cold. Now, some of the carbon dioxide, some of the dry ice is actually drifted up to the surface of the water, because the other thing that happens to the water is when it gets cold, it gets denser. It contracts. It squeezes into a smaller space without losing any weight. It gets denser, and now pieces of the dry ice that were frozen on the bottom come all the way up to the top and floated there. Now, not all of them. Some of it's still down the bottom. The bigger pieces are still down the bottom. But the little pieces up there on the top, floating around. You can see it down there at the bottom of your picture on the right side. And the reaction's almost done. It doesn't look like the water's going to freeze, but it's going to be mighty cold. Well, this will give you an idea of what dry ice is, what dry ice does, and what dry ice is used for, and why. Well, on that bubbly note, it was nice talking to you. So until next time, bye-bye.